next few examples then in our roots of polynomials. So the roots of the equation 3x squared plus 4x minus 5 equals 0 are alpha and beta. Find the values of 1 plus alpha and 1 plus beta. So let's first of all write out what we do know about this. So we know that alpha plus beta is minus 4 over 3. And we know that alpha beta is minus 5 over 3. That's what we've been doing. We want to try and rearrange this so it looks more in this sort of form here. That's terribly explained. If I take 1 over alpha plus 1 over beta and join it together as a common denominator, times top and bottom here by beta, times top and bottom by alpha. When I rearrange, I'm then going to get alpha plus beta all over alpha beta. We need to find the value of this, which is the same as this. That's why I have my equal sign there. We know alpha plus beta is minus 4 over 3. We know alpha beta is minus 5 over 3. Hopefully we can see you're happy enough with the fractions and cancel the minuses there. And we end up with 4 over 5. We're looking for a similar method then here. We're going to use this information here obviously for this part. But the trick to this is taking the alpha plus beta all squared. If you multiply that out, that's alpha plus beta upon alpha plus beta. So you get alpha squared plus 2 alpha beta plus beta squared. If I take this over to the other side, it ends up being alpha squared plus beta squared. Now I've reversed this, so hopefully we're okay with that. Alpha plus beta all squared, take away 2 alpha beta. So I've just written this out again when we've taken this over the other side and then flipped everything around. So how does that help us? This is what we're asked to work out. This is it here, and we know it equals this. We know alpha plus beta, minus 4 over 3. We know this is minus alpha beta is minus 5 over 3, so we can just do our sums in from here. So alpha plus beta squared, so that squared would give us 16 over 9. Take away 2 upon minus 5 over 3, so it's actually going to be plus 10 over 3. Sticking it all in over 9, 16 over 9 plus 30 over 9 gives then 46 over 9. So hopefully you can see where that comes from. We want to try and get these into a format that we know and rewrite them so we can get it in some sort of alpha plus beta and alpha beta form. Example 4 then, a bit of a tricky one as well, but let's take a little look. So the roots of the equation 2x squared minus 7x plus 4 equals 0 are alpha and beta. Find an equation with integral coefficients whose roots are alpha over beta and beta over alpha. So what do we know again about this one? So let's write it the same as we did last time. Alpha plus beta is 7 over 2, remember it's the minus, and then alpha beta, sorry, is equal to, so that's 4 divided by 2, so that's just a 2, and that's okay. Let's work out, these are the new roots, so we want to find the equation now, so let's find the sum of these two. So we're going to write the sum of the new roots. So the sum of new roots is obviously going to equal alpha over beta plus beta over alpha. Finding our common denominator here again, we're going to times top and bottom here by alpha, alpha squared, times top and bottom here by beta, beta squared, and then alpha beta. So that's now in a format that we can deal with. Alpha squared plus beta squared, if you remember we had it back up here, so let's go back up to this previous example. We know alpha squared plus beta squared is actually just equal to this, so if we can rewrite this in that format there, it's going to be alpha plus beta all squared minus 2 alpha beta all over alpha beta. So just about be able to fit this in here. Alpha plus beta squared, so it's 7 over 2 squared, so it's going to be 49 over 4. Take away 2 alpha beta, so let's take away 4 all over 2, and put it in your calculator, just do your sums and work it out. We end up then with 33 over 8. The product of the new roots I think is almost a little bit more straightforward, so let's see. Is equal to alpha over beta multiplied by beta over alpha. That gives me alpha beta all over alpha beta. I don't care what it is. It's 2 over 2, which is of course going to give us 1. So what do we know about our new equation? We know that minus b over a equals 33 over 8. So it looks like here we're going to have an 8x squared minus 33x, and then we know that c over a is 1, so we need to make this a 1 then, so that's then going to be plus 8 equals 0. So that's going to be our new equation. I hope we can follow that and see where it's come from. Let's look at one more example then, and that should do us the roots of the quadratic equation x squared minus 6x plus k equals 0. Sorry, find the roots given that one root is 3 times the other and that k is a constant. Find also the value of k. So normally we would let our roots equal alpha and beta, but they're related this time. One root's 3 times the other, so we are going to let the roots be alpha and 3 alpha. We also know that the sum of the roots, alpha plus 3 alpha, must equal 6. Do you see that? The minus b over a there a bit, so minus 6 over 1, so it's a minus minus, and we end up then with that. That means alpha is of course equal to 1.5, and then the other root is 3 alpha, which is going to be 4.5. What about the k bit? We know that the two roots multiplied by each other, because c over a must be equal to k, so the product of the roots is k over 1, so the product of the two roots are alpha and 3 alpha. That's supposed to be a 3 there, so I just badly written. We know that equals k, so that means k must equal 1.5 multiplied by 4.5, because we know that that's what they are, and that then is going to give us 27 over 4. So a slightly unusual question there, not particularly standard. The previous examples are probably more what you're looking for, but that gets us through that one now.